Let's look at question number 3. A supermarket uses 2 suppliers of strawberries, C and D. Supplier C provides 70% of the supermarket's strawberries. The strawberries are examined in a quality control inspection, QCI. It is found that 90% of the strawberries supplied by C pass QCI and 95% of the strawberries from D pass QCI. And then we have a bunch of questions over here. Let's draw a tree diagram for this. Let's call that one C there. That's supplier C and supplier D. It tells us that 70% of the strawberries come from C, and so we can assume that 30% come from D. Next step is to have a look what it says here. It is found that 90% of the strawberries supplied by C pass it, okay? So we can put down now pass and not pass. We'll use that here. So we've got pass and not pass. Pass and not pass. And it said that 90% of the strawberries supplied by C pass. So we can put 0.9 here, but that would be then 0.1. And 95% of the strawberries from D pass. So we can put 9.5 here and 0.05 there. Okay, so that's our tree diagram. Let's have a look at the first question. Strawberry selected at random. Find the possibility that the strawberry passes QCI. Well, this pass, those two there, they're the ones where they pass. So we've got to multiply that by that. We write that. This by that, and we write that, and then we add down. Remember, you multiply along the branches and add down. Let's do A. This is the probability that it passes. So it passes. That's going to equal 0.7 times 0.9 plus 0.3 times 0.95. And that equals 0.915. Good. Next question. Given that a strawberry passes, find the probability that it came from supplier D. Conditional probability. So, the previous question has given us the denominator for this question, B. It says, given that a strawberry passes, well, that's what that is. So we know we've already calculated that. Remember, every time you see the word given, just write that straight on the bottom. Okay, so we're going to write that here, 0.915. Given that a strawberry passes, find that. So we're looking at this one and find the probability that it came from supplier D. So we're just interested in that. We're interested in that, and now we've got to take this and put that on the top because it came from D. 0.3 by 0.95 on the top. And that equals 0.3115. Okay, and now C was in a sample of 2,000, find the expected number of strawberries that would fail. Well, we looked at A gave us the strawberries that passed, so the strawberries that fail would be P fail, and that would be 1 minus 0.915. I'm getting that from here. Okay, and that's 1 minus that, and that would equal 0.085. Okay, and then they ask us here in a sample of 2,000, so we've got 2,000 and we multiply it by that. We'll see what we get. Therefore, 2,000 times 0.085, that equals 170. And then D is the supermarket wants the probability that a strawberry passes QCI to be 0.93. Find the percentage of strawberries that should be supplied by D to achieve this. We're going to go back to this one, okay, because we're talking about the probability that something passes. And what they want us to do is to change this percentage. They want to know what that percentage would become to get this to equal 0.93. Well, if you change that, that's going to change in tandem to that. Okay, so let's have a look how we might express that. Okay, now the new number is 0.93, so we'll put that as 0.93 equals. I'm going to put, we'll put this as x, so if that's x, this is going to be 1 minus x. They have to add up to 1. Okay, so that's 1 minus x. 1 minus x times 0.9 plus x times 0.95. Okay, good. And then we expand that, and we've got 0.9 minus 0.9x plus 0.95x. Okay, so we're going to move that 9 over here. We've got 0.93 minus 0.9 equals 0.95 minus 0.9x. And that gives us x equals 0.6.